In this video, we will learn how to construct a confidence interval for a proportion. Before watching this video, you should watch the video called Confidence Intervals Introduction to get the the foundations for doing confidence intervals. In there you will see that there are a number of different kinds of confidence intervals you can create, and one of them is for a proportion, and that's the subject of this video. Remember, when you construct a confidence interval, you are using information from a sample to estimate something about the population that the sample came from. When you construct a confidence interval for a proportion, you are using the sample proportion, which is called p hat, to estimate the population proportion, which is called p. That's so important, I'm going to say it again. When you construct a confidence interval for a proportion, you are using the sample proportion, p hat, to estimate the population proportion. So our end product is an estimate of the population proportion. We're going to do this on the calculator. And to do this, the calculator will take the sample proportion and add and subtract something called the margin of error to get an estimated range of values for the population proportion. That range of values is called an interval, and that's why we call these confidence intervals. So what exactly is a proportion? A proportion is the same thing as a percentage or fraction. If 20 students are in a classroom and 12 of them are females, we calculate the proportion of females as follows. The numerator of the fraction is the number of females, which is 12. The denominator of the fraction is the total number of students in the class, which is 20. So, the proportion of females equals the number of females over or divided by the number of students. The number of females is 12. The number of students is 20. That fraction is correct. That's a correct answer to this, but we can simplify it down to 3 over 5 if we divide the top and the bottom by 4. We can also express it as a decimal, which is 0.6. We can also express it as a percentage. To find the percentage, you take the decimal, you move the decimal point over 2 places, and you put in a percentage sign. So I'll repeat, notice that the proportion can be written 3 different ways, all of which are correct. It can be written as a fraction, it can be written as a decimal, it can be written as a percentage. Having said that, especially if you are doing online homework, pay attention when they tell you how they want your answer. Most of the time they will tell you that they want it as a decimal by telling you they want you to round to a certain number of decimal places. I'm here on this bullet now, right here. If this classroom of 20 students is treated as a sample, then the proportion of females in the classroom would be the sample proportion, which is p hat. That's the symbol for sample proportion. So, going back up here where we said the proportion of females equals all these things, now using notation, we can also say p hat equals 0.6 or 0.60. Also, we would call the number of students in the classroom n and the number of females x. So we could also say p hat equals x over n. And in this case, that's 12 over 20. That's 0.6. So it is important to remember this formula for p hat. P hat equals x over n. That's an extremely important formula for this chapter. Notice something else, and now I'm down here at this bullet. If we multiply both sides of this equation by n, then we get n times p hat equals x. This formula is extremely important because very often a problem will give you n and p hat, but it won't give you x. And you need to put x into the calculator. So you will use this formula to find x, and you can then put x into the calculator. And now before we actually do some problems, we're going to talk about what does a confidence interval for proportion look like. Remember, we said that the calculator will take the sample proportion, p hat, and add and subtract the margin of error to get an estimated range of values for the population proportion, which is called p. We can express this a couple of different ways. Here you see P, and I'm going to take some time explaining what every part of this is. P, remember, that is our estimate of the population proportion. So our estimate of the population proportion equals P hat, that's the sample proportion that we'll get from the problem, plus or minus E, that's the margin of error. So we'll calculate one part of the confidence interval by taking P hat and adding E, and we'll calculate the other part by taking P hat and subtracting E. And actually, we won't do this. The calculator will do it for us. The other way to express this formula, or what I call the structure of the confidence interval, you see down here. Look at P in the middle. We're estimating P, which again, if you look here in the green highlight, that's the population proportion. And see these symbols here, less than, less than? When you put P in between two less than symbols, you're saying that P is between, meaning it's less than this number and it's greater than this number. So this whole business in the middle here, you simply say P is between P hat minus E, and again, P hat is the sample proportion minus the margin of error, so that's the little number. The big number is P hat plus E. So E is the same in both cases, but in this case we subtract it from P hat, and in this case we add it to P hat. And you'll see as we go through a problem that when the calculator constructs a confidence interval, it is really creating this thing that you see right here. Okay, let's do a problem. And here is what I call problem 1, internet use. In a Pew Research Center poll, 73% of 3,011 adults surveyed said that they use the internet. Construct a 95% confidence interval estimate of the proportion of all adults who use the internet. This problem is taken right from the Triola text, page 330, exercise number 37. The first thing we want to do is to understand the problem. And we're going to go through it real slow, step by step, and see how we do that. You see the word poll. It's right there. Poll means sample. So that means that what is coming next is information about the sample. Other words that mean sample are survey, study, experiment, randomly selected, etc. Anytime you see any of those words, it means you are getting information about the sample. Now let's look here. See the words construct a 95% confidence interval estimate. And here you see I've highlighted those words. They're so important. That tells you that this is a confidence interval problem. It tells you what you're going to be doing. Let's look at this third bullet. See the word proportion? That's right here. That word tells you that this is a proportion problem and not, for example, a mean problem. Because in other cases, you could be asked to construct a confidence interval estimate of a mean, and you would do that in a different way. So this word proportion is very important. It tells you how you're going to be solving this problem. And finally, this fourth bullet. You see the word all right there. That word tells you that what you are estimating is the proportion of the population. So whenever you see the word all, you can be pretty darn sure that they're talking about the population. So if we go back over this, they're giving us sample information. They're asking us to construct a confidence interval estimate, and it's an estimate of the proportion, and specifically it's an estimate of the population proportion. The next thing we want to do is to write down the sample statistics. If you look at the problem, it says 73% of 3,011 adults surveyed. This tells you that we're going to hear about the sample. Here's another word that means sample, is survey. So they're going to be giving us some sample information. For a proportion problem, the sample statistics that we need are N and X. N is the number of subjects in the sample. In this case, that is 3,011. 73% is the proportion or percentage of subjects who said they used the internet. Remember, the symbol for a sample proportion is p hat. So here we would say that p hat equals 0.73. Let's look at this fifth bullet here. So far, we know that n equals 3011 and p hat equals 0.73. But remember, we need x. And also remember, x equals n times p hat. So to find x, we multiply 3011, that's n, times 0.73, that's p hat, and we get 2198.03. But we must round x to the closest whole number. So in this case, the closest whole number would be 2198. So we say x equals 2198. And now we're going to use the calculator to construct the confidence interval. You see this first bullet here. It says go to stat tests 1 prop z int. So we're going to do that over here on the calculator. Stat tests. Now I'm going to scroll down and I want to show you something. See this right here? It says 1 prop z test. We'll see this over here. It says 1 prop z int. Those are not the same thing. You're going to be using 1 prop z test in chapter 8, but what we want now is 1 prop z int, and that is not it. So we must continue to scroll down until we find 1 prop, and there it is, 1 prop z int. So we're going to choose that. And you see, you don't have to input very much here. X, that's the x we calculated right here, is 2,198. So we're going to put that in there, 2,198. And then it wants n, that's 3,011. 3,011. The confidence level is 0.95. So we're going to go on down to calculate. We're going to hit calculate, hit enter on calculate. And there you see our answer. We don't need to worry about this p hat and n. We already know those. But here is the actual answer to the question. 0.71413, comma, 0.74585. And there you see those numbers right there in the calculator answer. In words, here's what we say. And this is sort of the long version. We are 95% confident. That 95% comes from the confidence level that was in the problem. We are 95% confident that the true population proportion of adults who use the internet is between 0.71413 and 0.74585. I'd like you to read that statement a few times until you start to get the idea. We're estimating the population proportion, and we're saying it's somewhere between these two proportions. And we don't know where, only that we're pretty darn sure that it's somewhere in between those two numbers. And that's how these confidence intervals work. You're coming up with an interval or a range of possibilities. Understanding the confidence interval. We're going to take a few minutes with this so we see exactly what we've accomplished when we do this. And really, all of this is happening inside the calculator, or most of it is. If you remember, one of the ways that we can outline what a confidence interval for a proportion looks like is this one right here that says P, that's the population proportion, is between the sample proportion minus the margin of error and the sample proportion plus the margin of error. So we're going to step by step, we're going to start filling things in to this equation here, or this technically this inequality. We're going to start with p hat. We know what p hat is because the problem gave it to us. That's 0.73. And by the way, when p hat in proportion problems is sometimes called the best point estimate. So you will get problems asking you what is the best point estimate. And if it's a proportion problem, That's simply the sample proportion, or p hat. It's no more complicated than that. So for each of these p hats, we're going to put in 0.73. 0.73. How do we get E? Well, right here, it shows you the shortcut way to get E. This is not finding E using the formula. This is basically backing into E when the calculator has taken us straight to the answer, the confidence interval. The way we back into E, or the shortcut to E, is to take the high end of the confidence interval, that's right here, subtract the low end of the confidence interval, that's right here, and divide that answer by 2. So here you see, this is how we're going to do it. Here we've done that subtraction. This minus this equals this, divided by 2. And that answer is 0.01586. So that is the margin of error. And that's how you can get the margin of error after the calculator has constructed the confidence interval for you. And many problems will ask you for both the confidence interval and the margin of error. And in most of these problems, you can do it this way. You can get the confidence interval first, and after you get that, then you can sort of back into the margin of error. So anyway, now that we have the margin of error, we can put that in place of each of these e's, and then we wind up with 0.73 minus 0.01586, that's the margin of error, and over here we have 0.73 plus 0.01586, the margin of error. And when we do this little bit of math here, this subtraction and this addition, we get these numbers right here, which is the confidence interval. I really encourage you, go through this passage a number of times and get to the point where you understand basically where these numbers come from. And the way that the calculator got to them is by going through this process. So now we're going to talk about understanding the margin of error. Above, you see the shortcut way to find the margin of error, and we talked about that a minute ago. You take the big number in the interval, subtract the little number, and then you divide by 2. It's that easy. But there is a formula for E, and again, when I say E, I mean the margin of error. And the formula is what the calculator uses to construct the confidence interval. For a proportion problem, the formula for E is this. E equals Z alpha over 2 times the square root of P hat Q hat over N. This Z alpha over 2 is called a critical value. I'm not going to talk here about how we find the critical value, but if you look at my video called Normal Probability, Finding Critical Values and Percentiles, it will walk you through how to find the critical value. P hat, as you know, is the proportion of the sample. Q hat is 1 minus P hat. N is how many are in the sample. So let's go through step by step how we're going to input values in for all these things and solve for E sort of the mathematical way, actually using the formula. So Z alpha over 2, the critical value is 1.96, and there you see I've got it called out as the critical value, times the square root of P hat, which is 0.73. Q hat, as I said, is 1 minus P hat, so 1 minus 0.73 is 0.27. N is 3011, and now we're just doing the math. This equals 1.96 times 0.1971 is simply this times this, still over 3011. If we now work out this fraction inside of the square root sign, we have 1.96 times the square root of this number, 6.546 e to the negative 5. If we take the square root of this number, we get 0.00809, so we have 1.96 times 0.00809, and that equals 0.01586, which is the same E, or margin of error, that we got by doing the shortcut approach up here. So that's how you work out the margin of error the long way, or using the formula, and that is what the calculator does so that it can calculate the confidence interval. So again, the answer to this problem is this right here. That is the confidence interval. And up above, if the problem asks you to state the answer in words, you see it right here. And now we're going to move on to the second problem. Actually, before we move to the second problem, I want to tell you that what we just did on the first problem, that same approach will work with just about every single confidence interval problem for proportion in the book. So all of the skills, the techniques you learned from doing that one problem should be fully applicable to all of the other problems. Just be aware that in some of those other problems, you won't have to calculate x. They will actually give you x, and that will make it a little bit easier. But now in problem 2, we're doing something a little different. And that is, instead of constructing a confidence interval, we're going to find a minimum sample size. Well, what does that mean? Pretend that you're in the business of conducting surveys, and a client comes to you and says, we need a survey to find out if our new drug works, or to find out if our political candidate would win the election if the election were held today. And we want you to do our study for us. Well, now you have to decide. One of the first things you have to decide is, how big does your study have to be? How many people do you have to interview, or how many people do you have to test? So that's your sample. The question is, how big does your sample need to be? And that's called a minimum sample size problem. And that's what we have here. Let's read this problem. Internet use. The use of the internet is constantly growing. How many randomly selected adults must be surveyed to estimate the percentage of adults in the United States who now use the internet? Assume that we want to be 99% confident that the sample percentage is within 2 percentage points of the true population percentage. And then they really ask you two different questions, very closely related, but they change it slightly. Question A says, assume that nothing is known about the percentage of adults using the internet. Question B says, and these are two separate questions, as of this writing, it was estimated that 73% of adults in the United States use the internet. And again, this question is taken right from the Triola text, page 331, exercise 41. So first we want to understand the problem. Do you see the words how many? That means this is a minimum sample size problem. I want to make that very clear. Those words right there, how many? As soon as you see those words, you know this is a minimum sample size problem. It is not a confidence interval problem. You are not being asked to construct a confidence interval. And that's what it says right here. It is not asking you to construct a confidence interval like the previous problem. In these problems, we are solving for n. If you remember, n is the symbol for the sample size. So we're going to find out, how big does our sample have to be? And then the other point, you look in the problem, you see the word percentage. I have it here in bold and underlined. That means we're being asked to find a minimum sample size for a percentage or proportion. They mean the same thing. And not for a mean. Again, later on, you will get minimum sample size questions that relate to a study of a mean. And those you'll do a little bit differently. So you want to focus on, what is it a minimum sample size for? Is it for proportion or percentage, which again are the same thing, or is it for a mean? Now we want to write down the variables that we're going to be using to answer this question. The first variable is the confidence level, and you'll see it's specified. It's 0.99. There you go, right there. We want to be 99% confident, so the confidence level is 0.99. Margin of error. Whenever you see the word within in a minimum sample size question, whatever comes next is the margin of error. So there you go. You see that word within? It says within 2 percentage points. So that is the margin of error. And we write that as 0.02 or 0.02. It's the same thing. So the margin of error is 0.02. And then the third variable we have to focus on is the sample percentage, or p hat. And notice these questions are different. Question A says, sorry about that phone interruption. Anyway, question A says, nothing is known about the percentage of adults using the internet. And I want to just show you right here. Question A. Nothing is known about the percentage of adults using the internet. In those cases where they say that nothing is known, or they don't give you another percentage, what you're going to use for p hat is 0.5. And notice, not 0.05, but 0.5. Don't confuse these two things. It's very important that you use this and not this. Question B is a little different. Question B says it was estimated that 73% of adults in the U.S. use the internet. So in this case for p hat, we'll be using 0.73. So the only way you can solve this using the calculator is if you come and see me, I can transfer a program from my calculator to yours, and that program makes it very easy to solve these types of problems. Unfortunately, this calculator over here doesn't have those programs, so I'm just going to have to tell you, once you have the program, how it works. So if we're working on question A, you're going to hit the program key, and that's right here on the calculator. You see that. And then you will scroll down till you see a program called nprop, and then you'll hit the enter key twice. So it says enter, enter. So you'll hit the program key, you'll scroll to nprop, and then you'll hit the enter key twice. And then the program will prompt you for all of these things. It prompts you for interval, and that's going to be the 0.99. It prompts you for sample p, that's going to be the 0.5. It prompts you for error, and that's the 0.02. After you type in each of those things, you hit the enter key. When you hit the enter key after error, it instantly gives you the answer, which in this case is n equals 4,147, and that is the answer. That is the minimum sample size for question A. Question B, almost the same with one little change. Again, program, you go to nprop, you hit the enter key twice. The interval is 0.99, but now the sample p is 0.73. That's something they gave you in question B, was that percentage. The error is still 0.02. You hit enter, and the answer instantly comes back, n equals 3,270. So that is the answer in that scenario. If you don't have the calculator programs, it is not that difficult to do the problem by hand. The biggest sort of obstacle is that you need to know how to find a critical value. So let's see here. Remember, and again, what we're doing is solving this problem by hand. When we do a minimum sample size problem, we are solving for n. The basic formula for n in a proportion problem, and again, this is a proportion problem, is n equals, and here you see it, there's this fraction. The numerator is z alpha over 2, which is a critical value. You square that, times p hat times q hat, and that's all over e squared. That again is if p hat is given to you in the problem. If p hat is not given, then the formula changes slightly. And the only change is right here. Instead of having p hat times q hat, you simply have times 0.25. So let's look and see how we solve question A by hand. N equals, again, here's this critical value, and if you don't know how to find a critical value, go look at my video called Normal Probability Finding Critical Values and Percentiles, and it will tell you how to find this critical value. In this case, the critical value is this, 2.5758, and that's squared, and times 0.25, because again, in question A, we do not know the sample p. The margin of error is 0.02, so that's e, and we have to square that. So now we work these things out. This whole business here works out to 1.6587. 0.02 squared works out to 0.0004. This all works out to 4146.75. And there's a rounding rule for whenever you're doing a minimum sample size question. The rounding rule says you always round up to the next whole number, no matter how big your decimal is here. So 4146.75 will go to 4147. If we do question B by hand, it's almost the same, except here, instead of having 0.25, which came from that right there, now we have to do p hat times q hat. And we know that p hat was 0.73, q hat was 0.27. So if we do all this in the numerator, we get 1.3077. The denominator, again, just like in the last one, 0.02 squared is 0.0004. This fraction works out to 3269.25. Again, in these minimum sample size questions, we always round up. So even though this 0.25 is less than 0.5, we still round up. So this answer becomes 3270, which is the same answer we got by doing it in the program in the calculator. And that is the end of this video on confidence intervals for proportions.